Okay. Okay, I think we can start now. You have already have the recording from these classes on your portal, but anyway, I have to run it. So today we have phase modulation. So this is the last our last meeting on about analog modulation technique. So we have another trainer kit for phase modulation and demodulation. So we can turn it on, and it consists of several blocks such as sine wave generator. Here we have sawtooth generator, which will serve as our carrier generator. We have comparator, modulator, demodulator, and low pass filter and amplifier, and power supply section. So
yes. Are you going to record the class?
No, the class is already recorded, so it's already on your portal. Okay.
Okay.
Because the other two groups already had this. Sorry, this meeting last week about phase modulation. So I have already uploaded it. Okay, so maybe let's look at the power supply section to see whether our trainer kit is working. Okay, we have +5 and here we have -5. Okay. So first of all, we're going to look at the at our sine wave generator. So we need to have a ground first. And on channel 1, so we don't need channel 2, we should already see the sine wave. I think one student asked about the oscilloscope multiplication, because sometimes we change the multiplication of the oscilloscope probe to ×10. So actually, this digital oscilloscope contains such function. Yeah, now it's, yeah, as you see now, it's set to ×10, so it should be set to ×1. But I didn't use it. So in general, when we focus on the values of what we measure, then I use the ×1 multiplication, so we don't need to adjust it. In other ways, is just to observe the waveform. So it shouldn't lead to any misunderstanding, but it's just good to know. Okay, so let's check what is the range of the frequency and amplitude of the sine wave generator. So we have two knobs. One is for frequency, the other one is for amplitude. I'm not sure it's much visible. Maybe this way. I think the camera is not focused on that part. Maybe something like that. Okay, so let's check the minimum frequency. We need to choose here what we want to measure. So we want to measure frequency and amplitude. Okay. So the minimum frequency is 180 hertz. And the maximum frequency is 2.26 kilohertz, 2.2 kilohertz. And now the amplitude. So the minimum amplitude is, yeah, we have 0 volts or 60 millivolts. So it's more or less 0. And now the maximum. No, it's not 20. It's 2.1 volt. So I'm going to set the frequency to 1 kilohertz and amplitude to 1.5 volt. And we're going to look at the spectrum in the frequency domain. Okay. So we set the frequency to 1 kilohertz and the amplitude to 1.5 volt. And let's look at the spectrum in the frequency domain. Here we have source channel 1. And now we need to adjust the scale. And we are going to read the peak frequency using cursor here. Type. No, we need to choose here source FFT and type frequency. Now we can read the peak frequency here. Yeah, it's here. So it's nearly 1 kilohertz. Okay, and now let's switch to the time domain, and we're going to look at the other block, which is sawtooth generator. Okay. So I'm going to take the second probe and connect it to the ground and to the output of the sawtooth generator. So we don't need channel 1. Okay, and here we cannot change the amplitude or the frequency, so it's fixed. So we can only read the values, but first, yeah, let's stop it. So again, need to press here, measure, choose channel 2 and choose frequency. And amplitude. And we can see that the frequency of the sawtooth generator is 25.9 kilohertz. And the amplitude is 3.1 volt. And let's look at the spectrum of it in the frequency domain. Okay. Okay, it's here. So the peak frequency here is 25 kilohertz. So this is the spectrum of the sawtooth generator. Okay. Maybe now let's compare these two input signals. So on the top we have sine wave generator, and on the bottom we have a sawtooth generator. Okay, and now we're going to connect these two signals to the comparator, and we're going to look at the comparator output. So we connect sine wave generator output to the input, first input of the comparator, and sawtooth generator output to the second input of the comparator. And now on channel 2, so on channel 2 we're going to have, sorry, I need to connect it to the ground. So we're going to have a comparator signal. And on channel 1, we're going to have either the sine wave generator signal or the sawtooth generator signal. So I'm going to switch between these two signals to show you how the comparator works. Sorry. One moment. Okay. So now we have a comparator on channel 2. And first, let's look at the sine wave generator. Okay. Okay, and so on channel 2 we have pulse width modulation signal, so PWM waveform. Yeah. So it generates the signal according to the difference in phase of these two signals, so of this sine wave generator signal and sawtooth generator signal. So when the sine wave signal is higher than the sawtooth signal, we have PWM signal in high state. And when the sine wave is lower, we have it in the low state. So maybe I'll switch to the sawtooth. And maybe I'll stop it. So in each case, when the sine wave signal is higher than the sawtooth, we have PWM in the high state, and when it is lower, we have it in the low state, so the 0 state. And again, so now we have Now we have PWM and comparing to the sawtooth generator, and maybe now we're going to again compare it to the sine wave. Okay. I wish I could have here 3 channels so I can show you actually how it works now. What we can do, we can switch between these 2 input signals. But you have it in the instruction list. It's described there. Okay, and now the comparator is connected to the modulator. So now we're going to look at the modulator output. So maybe one more time, I'm going to stop it. And we're going to look at the modulator signal on channel 2 and comparator signal on channel 1. Okay. Yeah, this way. So now we can see that the modulated signal is generated from this PWM signal. So we generate here. So we generate a constant wave pulse at the end of the duty time of each of these PWM pulse, as you can see. And when we change the amplitude of the sine wave generator, let's wait a few seconds. So now maybe let's look at the okay, more or less we can change it. Okay, and now we're going to connect the modulator to the demodulator. And we're going to look at the modulated signal. Here. And here we are going to look at the demodulated signal. And maybe let's compare it to the sine wave generator. Yeah, we forgot about the frequency domain. Okay, let's change the frequency of the input signal back to 1 kilohertz. Okay. So now we look at the demodulated signal. And now let's switch to the frequency domain and let's look at the signal in the frequency domain of the modulator and the modulator. Okay, so maybe first. So this is the spectrum of the modulated signal in the frequency domain. And now let's look at the demodulated signal in the frequency domain. And we're going to connect in a minute the modulator with low pass filter and the amplifier. And we're going to also look at its spectrum in the frequency domain. Okay, and now let's stay in the frequency domain, but switch to the low pass filter and the amplifier. Yeah, this is it. Not. Yeah, no. So again, we can see that here the low pass filter actually cuts the impact of the carrier. So the spectrum of the carrier signal. You can also read this peak frequency here. Using cursor. So the peak frequency of the demodulated signal after so passing the low pass filter is 1 kilohertz. So it's actually our sine wave generator frequency. Okay, and last thing, let's look at the, let's go back to the time domain and look at the signal of the low pass filter and amplifier. So this is the channel 2, so it's in blue. So we can see now. Yeah. Oh, that's it. Comparing to the input signal, which is in yellow. Okay, so when it comes to phase modulation and the modulation, it's more or less it, because we don't have any microphone signal here. So as I said before, you have this class already recorded, so it's already on ePortal, and you have already place to for your assignments, so for your reports to upload. So you have 2 weeks for that since today, I think. So thank you for today. Not sure if you have any questions concerning the reports. I know I have not marked you the reports, so I'm going to do it, I think today or tomorrow. And you're going to see your grades, your marks in the on your portal. Okay, so thank you, and see you next week. We're going to have the amplitude shift keying, so different method, not analog modulation this time.
Hi, I've got a question.
Mm-hmm.
For the report on FM frequency modulation, do we need to add the analog discovery bit?
Yeah, it would be a plus because we didn't look at the spectrum in the frequency domain on the using oscilloscope. So I brought this analog discovery module to show you the frequency domain spectra. So it was just better visible using this generator instead of the generator from the strainer kit. Okay, so I would like you to include this part.
All right, thanks.
Okay. Okay, so if you have any questions later, then you can email me. I try to answer your emails. And see you next time. Okay, bye.
Goodbye, have a good day.
Bye-bye.
Thank you, goodbye.